Hello. So let's write code for our problem statement. This is our first project, so I'll make it very simple for you so that our basics will be clear out in this particular small video. Now, I'm again writing out the steps here. First step is to frame the problem, then EDA, data cleaning, feature scaling, training, and validate metrics. So problem statement is that predict the median house value. So it is a GitHub datasets. You can simply download this here when you copy this thing and just paste here. You can simply download there, and or you can do one thing that basically I am retrieving from the URL, so I can use pd.read CSV to read the data here, and simply it will retrieve the data from the web. And this is a simple pandas command line, pd.read CSV. Then I'm loading this housing data set here. Data set, you can see it look like this. So I have longitude, latitude, the age, how many rooms were there, total bedroom, population, households, median income, median house value. So this is something we need to predict, median house value, and ocean proximity, how far it's from ocean. So we can see that there are some numerical data as well, and one is categorical. We can handle it very easily. I'll show you. So this is something we can from the visualization we can see that how it look like for us. So you can say whenever it is very near to the ocean, it is very costly, right? Near to the sea, it's costly. Median house value is very, you can say, large there. And I'm taking the population here, how many population are living here. So you can simply see that population is marked here. Then I see writing this housing.info. It will give me the basic information about my columns, that how many known null or what are the data type is there. So 2640 is the total rows, if I can show you. Um, lan is the inbuilt function. 2640 is the row. Okay. So you can see 2640 is there. Fine, fine, fine. But I can see that total bedroom is, in some cases, it's null. Right. So I wrote code here that how many null is there. So it will give me the true false, and any axis is one. In wherever I can see null, it will give me the null uh, rows. So I can see only in the bedrooms nulls was there, 9 is the nulls. So if null is there, then I can see that how many rows, 207, or simply I can check it from here again. Lan, I need to rerun this code again because I already have done the transformation and all. 207. So what I'm gonna do, I make a copy of it just because I want to keep the original file as it is. So I'm just making copy. Why not I'm assigning? Because if I do the changes here in the housing too, it will directly impact the housing data frame as well. So I need to make a copy here for safer side. Housing 2. So it's a categorical data. So general, sorry, it's a value data. So I'm gonna go with the median value. A middle value I'm gonna do, not mean, because I can show you the data how it look like. So pd.plot, or simply you can do one thing, housing. What is that? Total bedrooms. And which type of plot I want. Just simply pass it out, or you can pass the kind also. if you want specific type of data. So if I'm saying I want, I don't know I think histogram is generally using it. No. So what I'm gonna do, I'm Shift plus tab, click on it, so I can see what are the different data types it's providing me. It's saying bar, so let's say bar. Hmm, it's running right now. Let me interrupt this thing here. Look from the line. This thing can happen. So what I'm gonna do, I'm restart the kernel and kernel is running again. See, now it's working fine. Let me check what are the different by default thing I can see. It's a default line it will give. So vertical bar plot, bar h, histogram I want, hist. See, so these are the total bedrooms. If these are in the range between 0 to 1000, this the frequency of this is coming in our data set. So total is 20,000. So if you sum up, it will be 20,000. Now again, let's check what are the different data frame it's showing me. We can check density also. Hmm. So generally, more density is for this zero between 0 to 1500, right? That's why I'm gonna go with the median value. So what is the median value I'm getting hit? So I have calculated here. Let me check what is the median value. 435 is the median. It's very near to 435, right? This is you can say naturally it's about 400, 500 between. So that's why I'm gonna with the median value. Okay, housing 2 is done. We have checked that now it is resolved because I'm using the fill NA and column I'm putting median and in place is true means it will do that net original change in the housing 2. I don't need to reassign to the housing 2. Now there is one more way to do it. So that's why I'm going to use simple imputer here. It's a scalar library. So generally we need to put the strategy mean median mode. Again we can check with the shift plus tab on this simple imputer. Okay, we can check it. What are the different parameters it will ask? And strategy median housing 3 housing dot copy just because I don't want to do any changes in the original data frame. I'm using housing dot housing 3 again. It's a new data frame, so it will have the null value. So I'm now handling through this that housing 3 total bedroom and fit transform. So first it will fit the complete value means it will complete data set. It will fit that what are the nature of the median. Then it will transform the data frame this column total bedrooms. So I am using this 2D here is because otherwise it will make this series. So, but I don't want series, I want the data frame. So I keep it only one single column. It's a 2D data frame because two brackets are there. Right? It's a 2D. Housing 3 is changed now. So you can see now there are no nulls. Right? 2640 is coming here. There is no null. Housing 3 is done. Our data missing data values part is done. ED is done. Missing data values part is done. Now we need to do one hot encoding as well in categorical data. So what I'm gonna do is I'm using pre-processing one hot encoder. So if you don't know anything, we can simply click on one hot encoder and it will redirect me to the sklearn library, the document. We can easily follow this and do the needful, whatever the requirement in the problem, right? So this is one note encoding we can use here. There's a few examples already here. Let's say this, if I can tell you here. Hmm. So this, you can see female, male, female. Okay. So we can fit. First of all, we are gonna do fit, or we can use directly fit transform in a single column as single statement. So sparse output means it will not give me the output of sparse, but it will gonna change into the background. And header unknown ignore means, let's say that this sparse matrix I'm training on that this data. What is that? Test data. Okay. Sorry, training data. So when it change a new category come up in the test data, so it will ignore that warning, and what gonna happen means I fit on the data A, and when I'm gonna do transform data B, but in few cases there are chances that a new category come up, right? So in that time it will give me the none. It will not throw the error. It will just transform, or it will give me the none. So this is one way to do it. So fit transform I did already encoder fit transform. So it's in proximity again the data frame I wanted. Now the data frame, this is also a data frame. So I'm just concatenating this encoder F, but I want this particular encoder F. So let's check this encoder F type. I think it will be array encoder F. Okay, I need to I think tell what we have run this, because we have restarted the kernel, right? Array, it's array. So I'm just transform this in a data frame array and just providing the columns name. So this is the encoder. It will ask for the get features name out. So it will give me the columns value. Okay, I'm showing you again here. Encoder dot, what are the different methods are available in this object? It can give me here. So I want to check here. It's a you can say it's a features name out of this. If when I pass it this, it give me the different entries over here. So 1, 2, 3, 4, 5. So only 5 categories were there. So that's why it is giving me the features out. Make sense? Okay. So each and everything you can see that different class, ocean, inland, island, bear, near ocean is giving me 0, 1. So if it is ocean, then 1, otherwise 0. Simply similarly for inland, island, and rest others. When I'm concatenating these two, it gives me the final data frame. So you can see we have transformed successfully this ocean proximity in different 4 columns. Now I'm gonna drop this thing because this is not required anymore. So our data cleaning, data missing, and transformation part is done. Now we need to feature scaling this part, because you can see that one is coming 122 and this 8 very small, and some is coming very 0, 1. So it will take more time to train model. So I'm gonna use pipeline here. Otherwise, we can use directly standard scaler, but pipeline is a habit for me to transform 1 or 2 in a one go. So in using pipeline, I can even standard scaling, plus we can you can say train our model in one go. So this is just a good habit to you can say a very a good method to write code, and it will help us to concise everything in 1 or 2 lines. So I made a pipeline here just because I want to do it very differently, so that I am gonna use it. So I have scaled it. I have just first of all I need to, these are my independent variables, these are my dependent variables. So I have removed median cost value because this is what we have to predict. So this is our target variable, and this y is target value, so I have assigned this to the y x scale. So I have already made a pipeline of standard scalar. Simply I have to use fit transform, and now xdf is done because I need to, right, I need to have the columns as well as I want, because this x scale will be the array, but I want data frame again. You can see, just see, model will train on the array itself, but I want to see how it looks like, so that's why I have to use data frame here. Now we need to split the data using model selection, train and split, extrain, right, and very basic thing. So I need to give input axial y test. So y, so you, okay, it should be y. Okay, so you can see why I not use the y scale, because this is what I'm not. You can say not like scaling, because this is what I need originally, right? Otherwise, I have to do inverse transformation to find out the target value. It's not required here. So again, it split out data in 20%. So 20% we test and 80% test say. So again, you can see 2640 was the original rows value, but it will fall into xtrain for the 16512. Again, I'm making a pipeline for training model. So it's a linear regression. So xtrain, ytrain, I have fit and predict xtest in the white. Now I need to evaluate this model. So I'm using RMS because the regression problem. I'm gonna go with the RMS error and MAPE, which is mean absolute percentage error. So simply it will ask for the white test and white spread. Again, I got this value. MAPE is 28%, and I visualize this thing, and I have shown this residual plot, which means what is the difference between actual and prediction. So whenever it is small, it will fall into zero. Otherwise, it will, you can say if it's a positive side, then it is 20,000, 40,000. Otherwise, negative side, so it will go down. And this is the actual and predicted value. So actual is like a scatter plot. So if it is more aligned to the 45-degree line, then it means it's a very good model. I know this model is not good because we are using the very basic model here, linear regression, right? This theory part I am going to explain this in the next video, but till now you can understand that this linear regression model is just a benchmark model, but in coming videos we are going to use the more and more complex models to train our model. This is a very basic thing because I want to give you the flavor that how this machine learning project can be done, and it will boost your confidence that you can start working on it. In the next video, we are gonna come up with the new ideas, and I think maybe we have the classification coming up. So in the next video, we will understand how we can perform the classification problem in the machine learning, and also, and we are gonna deep dive into the more and much more. You can say a good formatting and all. This is very, you can say, what I have shown you is very uh, not a very good way to write code. It's a very raw method to do it. But in the next videos, and when we go to the 4 and 5 videos, you can say it will be the very, you can say habit. It will create a habit for you also, that you need to write a code in a such a manner that it will take more less space, and and also the output, you know how is it working in the background. So let's meet in the next video. Till then, thank you so much.